Hey, welcome to part 2. This is our chapter 6 chapter review, practice test. And we got through problem 5a, where we're trying to use the definite integral or integrals to express the area between the x-axis. And so we're trying to express the area, which is not always the integral. Again, in example 5, some of our graph in 5a had area above, and some of the interval had area below the x-axis. So we have to consider where we're crossing the x-axis on these problems. So let's take a look at B. This would be a real easy graphical analysis of where cosine of 2x hits 0. If we know that the graph of cosine, normally, plain old cosine, looks like this. Hopefully, from our pre-calculus days, we know that this looks just like the graph of cosine, except everything happens twice as fast. So when does this hit 0? This hits 0 at pi on 4, because everything would be happening twice as fast. This 0 at pi on 2. Well, pi on 6 is less than pi on 4, so the portion of the graph we're looking at would be all above the x-axis. Now, other options for this, you could say, well, cosine double angle, how are we on that? Is cosine squared of x minus sine squared of x. Or we could even solve this for 0, but I'm going to go this way. Equals 0. We could go cosine squared of x minus 1 minus cosine squared, Pythagorean, equals 0. Again, solving the double angle might be easier. I get 2 cosine squared of x minus 1 equals 0. So I get cosine of x equals 1 on 2, but plus or minus square root of. And that happens at 45 degrees or pi on 4. So same thing as we get here, and you could do the double angle. We solve this as a double angle, and we still would find out that from 0 to pi on 6, we have no worries. So all we need to do is find the integral of this. That will give us our area. If I define our area, that's right in here, all above the x-axis. Okay, so if I end with cosine, I must have started with sine. The derivative of sine, this is for antiderivatives, the derivative of sine is cosine, so I need sine of 2x, but the derivative of sine of 2x would be cosine of 2x times 2, so I need to cancel the 2, and there is our integral of this, and we are interested in 0 to pi on 6. So I get sine of 2 6 pi, or pi on 3, all on 2, minus sine of 2 times 0, all on 2. Sine of 0 is 0. Sine of pi on 3, if you have to build it, that's of course a 60. 180 divided by 3. This would be a 1, a 2, and a root 3. So we end up with root 3 on 2. Sine of 0, 0. So root 3 on 2. And they ask us first to express the area. So the area is root 3 on 2 square units. Next, they say evaluate the definite integral by hand. Well, the integral cosine 2x from 0 to pi on 6 is also root 3 on 2. And then finally, they ask us to check using fn int. I will leave that to the reader. Okay, suppose that f and g are continuous functions. We just had a quiz on this. That quiz went great in most cases. There's maybe a little bit of a tricky problem in here, but the integral of f is defined from 1 to 5 to be -2. From 2 to 5, the integral of f is defined to be 6, and the integral of g from 1 to 5 is -7. Therefore, the integral of g from 5 to 1, what's changed? We've reversed. Therefore, we just get, there's an answer line down here. I'm just going to put it here, though. We just get the opposite of -7, 7. This is the one that sometimes causes problems. So I try to draw a picture of this. We want the integral from 1 to 2. So if I notice my integral from 1 to 5 is negative, but from 2 to 5 is positive. So this is just a possibility. There's a lot of ways we could draw this. I'm going to go 1, 2, and 5. If the integral from 2 to 5 is positive, but 1 to 5 is negative, we've got to have a whole lot of curve under here. It could look something like this, where this area, it would even need to be more exaggerated down here. So this area from 1 to 5, if all of it is negative 2, and if this part of it is 6, what must the part from just 1 to 2 be? I think without a diagram, you may be kidding yourself here. This is the most commonly missed problem from our last quiz, was one like this. Well, if this whole area is negative 2, or this whole integral, excuse me, is negative 2, and this is 6, this must account for the remainder of it, so this must be negative 8. Okay, then, so we can still see our integrals up above. 4 times f from 1 to 5 would be negative 8, plus 7 times g from 1 to 5. Truthfully, there should be parentheses around all of this. From 1 to 5, g is negative 7, so 7 times negative 7, negative 49, and we get negative 57. Double check. 4 times negative 2, negative 8, 7 times negative 7, negative 49. One of the more common mistakes made on the quiz as well was just handling that. Don't be afraid to grab your calculator on that if you have it, or double check these things. Okay, integral from 3 to 3, well, we now have no width. From 3 to 3, our integral is 0. Okay, I had 3 or 4 people just leave that one blank, not know how to handle it. There's a little bit of a question in my mind of where we've been the last week. But for the most part, the overwhelming majority of class did very, very well on that portion. Okay, find the average value of f on a to b. Write the definite integral and solve analytically. Okay, so we are not responsible for the areas here, so I don't have to worry about if there's a 0 along the way. I just need the average value. So I want my integral from negative 2 to 4 of 1 minus 3x squared dx, and then that would give me the area, which is the y's, this is our y's, times our x's, in theory, infinity x's. So this is the area of the rectangle. What we need to do, we need to divide away the x distance to get our average y distance, and the x distance is 4 minus negative 2. From negative 2 to 4, we have a distance of 6, so we need 1/6 of this. So we need 1/6 times, let's go for antiderivative. If I end up with a 1 after taking a derivative, I started with an x. If I end up with an x squared, I started with an x cubed, but the derivative of x cubed is 3x squared, good, but I need a minus. So we need this evaluated from negative 2 to 4. So that is 1/6 times all of. Put in 4 and I get 4 minus 64. Minus, put in negative 2 and I get negative 2 minus negative 8. And we're going to take our time on this. Equals 1/6. If you don't have a calculator for this, or if this is on a non-calculator portion, we're going to take our time. We get negative 60. I get minus 6. So I end up with 1/6 of negative 66. So negative 11 after I multiply in our 1/6. We're going to restate the question. So the average value is negative 11. So there we have it. Just don't forget our 1/6. We have to read that carefully. A lot of times we're so focused just on integration. I would expect maybe a few people would just have a final answer of negative 66 here. So read it carefully. We have to divide away the x's to be left with our average y. Number 8, evaluate using the fundamental theorem of calculus part 2. So this is just integration as we've been doing it. So forget about the 2. Cosecant, cotangent. Well, the derivative of cosecant is negative cosecant, cotangent. So if I go with cosecant x, I need the 2. So now the derivative of this would be negative 2 cosecant cotangent. So I'm going to put a negative here. So we have this, and we are integrating from pi on 6 to pi on 3. So at pi on 6, we have a 1, 2 root 3. At pi on 3, we also have a 1, 2 root 3. So I need negative 2 cosecant of pi on 3 minus negative, oh yes, oh no, I'm good. Cosecant, sorry about that. Quick moment of panic. All right, and sine is y on r, so this is r on y, so I get negative 2 r on y, pi on 3, r on y, root 3 on 2. This would end up being plus 2 times cosecant r on y, 1 on 2, 2 on 1, 2 on root 3. I'll bet you caught that along the way. 2 on root 3, 2 on 1. So plus 2 times 2 on 1. So we end up with negative 4 on root 3 plus 4. Or if you like, negative 4 root 3 on 3 plus 4. And on the test it will state include details of evaluation of the definite integral. Doesn't say anything about fn int here, but if you have your calculator, you could fn int this, but I'm going to request that we leave answers as exact answers, but you could certainly check it. Okay, B. This is a problem that was in our homework set, maybe not 1 to 4, but this function was in there, and I think I had questions from that in all three classes. If we have a fraction and the denominator's a monomial, we can break that fraction up. So this would be 1 on square root of u minus square root of u on square root of u du. I'm going to just write this for integration purposes as u to the negative 1/2 minus 1 du. So if I end up after taking a derivative with u to the negative 1/2, I must have started with u to the 1/2. But the derivative of u to the 1/2 is 1/2 u to the negative 1/2. So I need to cancel out the 1/2 with the times 2. Derivative of negative 1, negative x. And now we are running that from 1 to 4 conveniently, since those are perfect squares. So we get 2 put in the 4, square root of 4, minus 4, minus 2 square root of 1, put in the 1, we get 2 times 2, 4 minus 4, 0, minus 2 minus 1, 1, we get negative 1. Okay, at that point I am going to take a break, and we'll be back with part 3 shortly. Well, shortly if you look at it. I'll be back with part 3 shortly, but we'll have all of this out here prior to Saturday.